All right, let's kick it off with another live stream here for covering real zeros of polynomials. And basically what I'm going to cover in this lesson is really just finding the real zeros by factoring. And we're also going to work into finding the real zeros, writing the equation when given the real zeros. So basically what we're just going to do is work on, I have 6 problems here, 2 problems writing the equation, and then we're going to get into some multiple choice. So once I finish the first first section, I will just kind of take a nice little break and check in with you guys in on the chat. Oops, I forgot to create this as a new live stream. So oops, I got to change the title. But either way, I guess I'll go back and check that out. Hopefully that went in check. So either way, we'll go through this live stream here or these problems and then get on our way with that. So let's go ahead and go through the problem. So the main important thing when we're looking into finding the zeros, we got to remember that the zeros is basically the x values that make f of x equal to 0 true. So we want to find the x values that make this true. Now, I created all these equations. I didn't have enough time to check them, so I might have made a mistake when I was checking them, or when we do them. So we'll go ahead and see, how I do. Hopefully, I did a good job for that. But the first thing we want to do is basically rewrite the expression. We want to solve for f of x when it's equal to 0. And we can write that, we can write this in a factored form, but whenever we're factoring, we always want to see, what common terms can we factor out first. And you can see that each of these terms here share an x that we can factor out. They also can be divisible by 3, so we can factor out a 3. So the first thing I'm going to set is 0 is equal to, and I'm just going to factor out an x. By factoring out an x is really kind of like factoring out a 3x. Factoring out a 3x is really the same thing as like dividing out a 3x out of each of these terms. So therefore, I'm going to be left with a x squared, a negative 2x, and then a negative 3. Okay, and now what we want to do is kind of similarly write this down. Oh, actually, let's see. And I also said write this as a linear factorization. So right now we have factored this, right? But what we want to do is factor this further. So every factor is to the first power, or at least of variables. And you can see here this is a quadratic factor. We want to factor this down to our factors. So basically we have a trinomial, and we want to see what 2 numbers multiply to give you negative 3, add to give you negative 2. And we can see that we can factor this one more time as x minus 3 times x plus 1. Okay, so that is going to be my linear factorization. We could write that, just as f of x is equal to 3x times x minus 3 times x plus 1. That's the linear factorization. And then from there, we can apply the zero product property. Now, I'm okay if you're not showing, the zero product property, or at least the work for the zero product property for all of these, because obviously it's going to take some time. But for this first one, I'm just going to kind of show, how we're getting our answers. So in this case, we'll just divide by 3, and we'll have x is equal to 0. Here, I'll add a 3, and we get x is equal to 3, and here I'll subtract a 1. Okay, so again, remember that the zero product property states whenever you have a product of 2 or more terms equal to 0, then you can set each and every one equal to 0, and that's going to satisfy that equation. So therefore, these zeros for each of these values, when they're equal to 0, 3, or negative 1, this whole equation is equal to 0, and that makes this true. So these are considered our zeros, and I'm going to write this in our set notation. So I'll do negative 1, 0, and 3. Now, the other thing it asks for is the multiplicity. And remember, the multiplicity is basically going to be the power of our linear factor. So that is going to be our multiplicity right there. And just remember from the graphical approach, if multiplicity is even, the graph is going to bounce. If multiplicity is odd, it's going to cross. And just remember, multiplicity not only can it be written like this, but it's a repeated 0. Now, all of these have a multiplicity of 1, so I'm just going to write with a multiplicity equal to 1. But whenever I'm dealing with zeros that are going to have different multiplicity, I'll write that in there. All right, so now let's get to the next one. Now you can see here this is a problem that comes up a lot with students, and they get confused with the x to the 4th because I can't factor anything out. So what I recommend doing is looking at this equation in terms of a quadratic. Okay, so we're looking in terms of quadratic, and basically I'm looking for what 2 numbers multiply to give me 4, add to give me negative 4. Well, in terms of quadratic, this would be x minus 2 times x minus 2. Right? And so the only thing that we're trying to do here is we're just trying to raise that top term to be a 4. So what I'm going to need to do here is I will have the same factors are going to be the same, x minus 2 times x minus 2. But now you can see what's happening here is I'm going to raise these. Did I do 2x minus 2 squared? And if you were to go ahead and multiply this out, which I did not do a correct answer. I did not want to use 2. Dang it. Crap. Let's go ahead and change this. Did I do this in class? Which one did I do? I did 16 or I did 9. Crap. Well, either way, I guess I'll solve this one and then you guys can kind of see what my problem here. So again, I did make a mistake here because this ends up being x squared minus 2, x minus 2. So if I was going to solve these, it would be x squared minus 2. And you can see it's actually the same 0 here. So is equal to 0. So you add a 2, x squared is equal to 2. Take the square root, x is going to equal plus or minus 2. But what you can notice here is that if you were going to write these as your zeros, and again, I didn't want to get to this in this section. Oops, I'm sorry, that's the square root of 2. What you'd see is x minus square root of 2, x plus square root of 2. That's the factored form. X minus square root of 2 and x plus the square root of 2. Now, that is not what I was actually intending to be able to get. I should have changed this problem because we haven't talked about irrational zeros yet. So those would be the zeros, and these both have a multiplicity equal to 2. So I'm going to do a little change because I'm going to change the homework here. I'm going to say, what about if f of x was equal to x to the 4th minus 2x plus 1? Let's do this one because this one sounds fun. Or this is the one I did in class. Maybe, I don't know. Either way. Again, if we were to factor this, you would factor this into, well, x minus 1 times x minus 1, right? But we got to raise the powers here because we got to get to x to the 4th, so that would be an x squared, and this would be an x squared, okay? So now, again, if we need to factor these, you can see these are two difference of two squares. So this is x minus 1 times x plus 1. This is x minus 1 times x plus 1. And you could write the linear factorization that way, or you could see that x minus 1 is repeated. So you could write it as x minus 1 squared times x plus 1 squared. So when we're writing our zeros, and again, I chose a problem that we haven't talked about irrational numbers, and I kind of set myself up for this, saying I didn't check my answers here because I had to make this, today that I wouldn't have them correct. But either way, we can see the zeros are going to be negative 1. And that is going to be a multiplicity of 2, because that's the power of the factor here, or negative 1, yeah. And then we have another 0 at 1 with a multiplicity equal to 2. Okay, so that's at least something. The main important thing here is, factor them kind of like a quadratic, but then raise the powers up from there. All right, let's look at the next example here. You can see in this next example, we don't have any numbers, but we can see that we can factor out a x cubed, right? And remember, when you're dividing out an x cubed, x to the 5th divided by x cubed, you subtract the powers, right? So that's going to be an x squared, okay? So I have 0, factor out an x cubed, and that's going to leave me with an x squared minus 16. Now again, I need to represent this as a linear factorization. This is not written as a linear factor. So I'm going to need to write this out as, and then sometimes you can write this x cubed. If you want to understand the multiplicity, you could also write this as x minus 0 cubed. And this would be a difference of two squares. So that's x minus 4, x plus 4. You don't need to write it like that. You can leave it as x cubed. It's perfectly fine. The reason why I like writing this notation is because going back to the definition of multiplicity, our 0 is 0, right? It's x minus 0. And you can see that m represents that multiplicity. So when I write my zeros here, I have 0, which has a multiplicity equal to 3. And then I have negative 4. That was not a negative 4. Let's say this. Let's do plus or minus 4. And those have a multiplicity equal to 1. And I think that's everything I was asking to do, right? Find the zeros, multiplicity, and then write as linear factorization. Okay, so if I wanted to write this as a linear factorization, I kind of forgot about that. F of x equals, we can just write that as x cubed times x minus 4 times x plus 4. Okay, and I wrote out the linear factorization here. I'm not going to, actually I can, yeah, you can see the linear factorization is there, and this one. F of x, you can see that one there. So, all right, one more here for raising the power of the factors. Let's see if I did this one the way that I wanted to. So in this case here, again, we're going to set this equal to 0. And now we need to factor this. Now again, if you're having trouble with this, think about this as a quadratic. X squared minus 10x, 10x plus 9. Okay, this is really the same thing, but as a quadratic. And if I was to factor this, I would factor it as what two numbers multiply to give you 9, add to give you negative 10? Well, that's x minus 9, and that's going to be x minus 1. So these factors are going to be exactly the same. The only difference is we need these factors to multiply to give us x to the 4th. So I'm just going to raise the power. And again, if you're having trouble with this, like multiply this out. When you do this, you'll see that the first two terms, x squared times x squared, gives you x to the 4th. Negative 9 times negative 1 gives you positive 9. And then my inner and my outer, negative 9 times x squared and x times negative 1, add up to give me negative 10x. However, you can see again, this is not written as, this is not my linear factorization yet. I could use the zero product property like I did up here. You can set each one of these equal to 0. So you could say 0 equals, x squared minus 9. Add the 9, take the square root, so x equals plus or minus 3. And then you could have, x squared minus 1 equals 0, so x equals plus or minus 1. The problem with this method is it doesn't, help you with the multiplicity. And that became apparent over here, because if you were just to solve these, you'd be like, oh, plus or minus 2, and you wouldn't think of multiplicity here. But what you see is when you factor it out, you can see that these zeros repeat themselves. And again, the black and the blue are completely different problems. So what we want to do, what's usually helpful, is to factor these out using difference of two squares. So 0 equals x minus 3 times x plus 3 times x minus 1 times x plus 1. And you can see here my zeros now are 3, negative 3, 1, and negative 1. You could use the zero product property, set them all equal to 0 and solve. But you can, hopefully you can see here, those are your zeros. So we're just going to do plus or minus 3, comma, plus or minus 1. And these all have a multiplicity equal to 1. And my linear factorization, as far as f of x goes, would just equal x minus 3 times x plus 3 times x minus 1 times x plus 1. And the linear factorization is really, really helpful to be able to identify the zeros, identify the multiplicity, because when you're identifying multiplicity, it's very important that you have them written as a linear factor, and it's that factor raised to 1. And just remember, the multiplicity is repeated. If you have more than those factors, like you can write them as squared, so it's a repeated 0. All right, so now let's get into another example here. In this example here, I can factor out an x. So I have a, 0, let's factor out the x. And by factoring out the x, I'm left with a x to the 4th minus 13x squared plus 36. Okay, so in this case, I have a little extra x, and that's fine. I'm going to want to see what I can factor this. So I'm just going to think of this as a quadratic and think of, I know I'm going to have to raise the power. So I think of this and I say, what two numbers multiply to give me 36, add to give me negative 13. Can I do this the same one? No, it's different. So you can say, oh, okay, that one's going to be, let's see, x minus 4 and x minus 9. But again, remember they need to give me x squared, x to the 4th, I'm sorry, so they're both going to be x squared, and then I can rewrite that as a linear factorization by, again, just factoring these down further into x minus 2 times x plus 2, difference of two squares, x minus 3 times x plus 3. Okay, so my zeros, again, all my linear factors have a power of 1, so the multiplicity is 1 for all of my zeros, which is 0, comma, plus or minus 2, comma, plus or minus 3. Okay, and I'm just going to leave this as my, and I'll just say my f of x as my linear factorization. Okay, so you can, or we'll just say equals my linear factorization right there. Kind of being a little lazy right now, just to kind of make sure I have enough time to get through this. So there you go. Obviously, you'd want to rewrite that as a linear factorization f of x equals that. But I want to get into this next example, which has 4 terms, and that's a little bit different than being able to factor with 3 terms. So, when we have 3 terms, obviously we're looking into 2 binomials squared. But in this case, when we have 4 terms, we can't think of what 2 numbers multiply to give you 12 and then go from there. So what we're going to want to do is use the grouping technique. And for the grouping technique, basically what I'm going to do is I'm going to group the first 2 terms and group the last 2 terms. And now what I'm going to do is I'm going to factor out the greatest common factor of each of these groupings. So I'll have 0 equals, now what common factor can I take out of 2x cubed and 3x squared? Well, I can take out an x squared, so it'd be x squared. And then here I'm going to be left with x squared, so I'll be left with a 2x plus 3. Actually, let's use black again. Okay, and then we want to look at, well, what can we take out of here? Well, you can see you can't take out a number like -8, but you can take out a -4. And if I take out a -4 left over, you can see that I'm going to have a positive, sorry, that's supposed to be an x. I knew I was going to make some mistakes. That's just, I'm sorry, not an x, that's supposed to be just, yeah, that's supposed to just be an x, so there's not x squared there. So I did make a couple mistakes. Sorry about that. So if you take out a -4, you're going to be left with a positive 2x plus 3. Okay, so now here comes the tricky thing. Now what we're going to do is we're going to factor out the GCF again from both of these terms. You can see these are terms here separated by subtraction. So you want to say, what do these have in common? And you can see that these both share inside parentheses 2x plus 3. So I'm going to want to factor that out, the 2x plus 3. And you can see what's left over is the red, which is x squared minus 4. And again, if you're kind of a little confused on that, just multiply 2x plus 3 times x squared, you get this. Multiply 2x plus 3 times -4, and you get this. So you can see that by multiplying it back, the factoring works out. And then now I can just expand this further for my linear factorization. This is linear, but this one is not. So I'm going to want to continually factor this one more time. And this would be a x minus 2 times an x plus 2. Okay, and that's going to be my linear factorization, and therefore if I want to write my zeros, we could set this equal to 0, right? Just a little FYI, so let's do that one. 2x plus 3 equal to 0, subtract a 3. 2x is equal to -3, divide by 2, divide by 2. Writing on the side, or angled, is -3/2. So that's -3/2, and then I'm going to have plus or minus 2. And all of these have a multiplicity with 1. Okay. Now I will be getting into this. We'll take a break here in just a second, and then I'll check into the chat and kind of see what any kind of questions you guys have, and see any kind of questions you guys have to go ahead and finish this up. So the next one, and obviously then we'll get into the multiple choice. So the next one is write the equation of the polynomial given the zeros. So in this example, what we're trying to do is given the zeros, we're trying to write the equation of the polynomial. And the main important thing what I want you to understand is we're basically going, did I do it from this one? No, I didn't even show, oh no, for this one. Okay. So basically what we're doing is we're taking this problem, the steps I showed in this first problem, and we're working backwards. See, here are the zeros, right? So if you're given the zeros, you can set them equal to 0, and you can see that from each one of these are what we call the factors, right? These are the factors. And remember, the factors multiply to give us the polynomial. So that's exactly what we're going to be doing here. We're basically going to take our zeros, and we're going to set each of these, our zeros, equal to x. Now, I hope I have enough room here. So x equals, let's zoom back in, x equals -3, x equals 3, and then x equals 1. Now, you can see that 1 has a multiplicity of 2. I'm going to come back to that in a second. For right now, I'm just going to deal with my zeros, because that's just a repeated 0. I could write it twice if I wanted to. You could write x equals 1 because there's a multiplicity of 1, but Well, actually, let's do it for that one because I have a multiplicity of 3 here. So we'll do that. So now I can take my zeros and set them equal to 0. So to set them equal to 0, you just get them to the same side with the x, right? So you subtract 1 on both sides. Subtract 1 on both sides. And what you can see is I have x plus 3 equals 0, x minus 3 equals 0, x minus 1 equals 0, and x minus 1 equals 0. Now, I don't really need to do this step, but what I'm trying to convey to you is I'm doing this step because I'm basically I'm working my way backwards, right? You have them set equal to 0, you set them equal to 0, and now whatever is equal to 0, that's your factor. And you can write your factors multiplied by each other. We don't need to write them multiplied equal to 0. We need to write them multiplied equal to our function f of x. So you can see here my function f of x is going to be x plus 3 times x minus 3 times x minus 1 times x minus 1. Because again, remember that multiplicity tells us it's a repeated 0, right? This happens twice. So I can multiply this now. Now I have this in my linear factorization form. Now I just need to multiply it. So x plus 3 times x minus 3 is going to be x squared minus 9, right? Difference of two squares. And then this can be written as x minus 1 squared, which hopefully you recognize that we can use FOIL here to multiply that out, actually expand that. So let's do that. Let's see, x squared minus 9. You could expand this to give you x squared minus 2x plus 1. All right, and now basically we just need to multiply this out. So I will do that here. Let's do distributive property. So I'm going to do x squared times each of these terms, and then I'll do a negative 9 times each of these terms. Okay, so therefore I'll have x to the 4th, negative 2x cubed. X squared times 1 is a positive x squared. And then I'll have a negative 9x squared, positive 18x, and then a minus 9. And then my final answer is just going to be a simplified version of that. So x to the 4th is a lone term. I don't have any more cubic terms, so that's going to be a minus 2x cubed. You can have x squared minus 9x squared, which is going to be a negative 8x squared. I only have one linear term, so that's going to be plus 18x, and then minus 9. All right, cool. Let's get into the last example here. Now, in this one, again, we can kind of do the same thing. And we can do the same thing like setting this equals 0, but rather than writing like x equals 0, let's just keep the multiplicity at the end, all right? Now, the other thing I want to mention is if I have x equals to the 1/2, all right, rather than writing my factor as x minus 1/2, subtracting a 1/2 on both sides, we don't want to write our polynomial with fractional coefficients, all right? So what we're going to want to do here, instead of just adding a 1/2 over to the other side, what we're going to want to do is multiply by 2 on both sides. And then what you'll get is 2x equals 1. And now what you can do is subtract a 1 on both sides. So therefore, you'd get a 2x minus 1 equals 0. And now that is going to be your factor. If I was going to do this one, x equals negative 3/2. All right, I know I'm going to have to multiply 2 and then add a 3. So therefore, this would be a 2x plus 3 equals 0. And again, you can check your work, like subtract 3, divide by 2. But either way, all of this work is just so I can identify my zeros or my factors, which is basically going to be 2x minus 1, 2x plus 3, and x. But remember, x has a multiplicity of 3, so I'm going to add that as a power. So let's write out my linear factorization. So that's going to be x cubed times 2x minus 1 times 2x plus 3. Okay. Now again, from the linear factorization, we're not trying to find the zeros. We're given the zeros. From the linear factorization, we're trying to find the polynomial. So we just need to multiply them out. So I can just use, FOIL here. First, middle, inner, and last to multiply this out. So I'm left with x cubed. Let's see what we get here. We have 4x squared plus 6x minus 2x minus 3. And then I can combine these to give me a 4x. And then now I'm just going to multiply my x cubed times everything So I have f of x equals, let's see, x cubed times 4x squared is going to be a 4x to the 5th. X cubed times 4x is going to be a positive 4x to the 4th. And then x cubed times a negative 3. Oh, I hate when that does that. And then x cubed times negative 3 is going to be a negative 3x cubed. Whew! A lot of math going on here. And so you can see basically just a little recap of this first section. We just kind of worked on factoring, finding the real zeros of factoring. These are real zeros, but they're irrational, and we're going to be talking about that next class period. So that's why I didn't want to include this answer, and that was just my mistake. I apologize for that. So I did work out another example here where it follows a little bit long what we kind of covered in class today. So what I'm going to do here is just take a little break, check in with you guys that are in on the chat. For those of you that are kind of following along and you want to maybe practice some of these multiple choice questions, I got 3 of them over here that you guys can go ahead and work on as I kind of check in here. Let's see here. Is anyone else even in his class? So I don't know. Who knows who's in class? Who knows what they're writing? Mohammed, great brand. Thanks. You are very welcome. Chef Raymond, hey Brian. I got an IB test in 7 hours on sequence and series, and I barely understand like 40% of the material. Any idea what I can do to try to make sense of most of it? Well, I mean, it's kind of hard. I mean, just the main idea, is, I mean, there's a lot. I mean, understanding sequence and series is a very broad, thing to ask. I would say, obviously, you're on YouTube. I'm sure you've probably been looking at some videos, and, looking to there. I would, make sure that you're just comfortable with geometric and, arithmetic sequences, just understanding the basics, because really when times it gets to the test, I mean, it's just going to be applying the knowledge. So, really just kind of make sure you have some of those fundamentals, down as far as what is a sequence, what is a series, making sure you know all the formulas for all those series, making sure I know how to identify the first couple terms of a sequence, making sure you know how to, know the formulas for geometric and arithmetic sequences as well as series. And, I think just, practicing some problems, practicing some basic problems, watching some videos and then understanding it and then trying to do it on your own and then going back to the video to see how you did, as far as getting the same answer, that's great. I have obviously a whole playlist on sequences and series, that you can check out, but, obviously there's a lot of other creators out there that have that as well. She is the best. So that's great. Hey, Ethem, Brian. Well, thank you so much, man. I really appreciate the super chat. That is, very kind of you. I'm so happy to be able to help you out with your math. That is, that is why I'm here, to kind of stay after. Obviously, I've already taught today. I taught 3 lessons on zeros of equations, and I wanted to kind of go over the homework, obviously for my own students, but it's for students like. For students like you with them as well that, really benefit from, the instruction and stuff I'm going over, that keeps me wanting to keep on going online, keep on making content, for you guys. So I really do appreciate that. Matt just says he randomly found me and helped me with your homework. Well, happy to be able to help you out, Matt. Hey, Summer, how are you? Fortnite? No, I don't have any Fortnite. My nephews do, but that's okay. All right. Well, if you guys don't have any questions, if you don't have any questions, I'm going to go ahead and get started on these multiple choice ones. But if you do have anything coming up in your class, I will probably finish up here. I don't think it should probably take me maybe 5-10 minutes. So 10 minutes to wrap this up, and then maybe I'll answer any of the other 5 questions. So Mo Soccer, you're a great guy. Well, just happy to be able to help any way I can. You are very welcome. Creeperzania, I guess that's what your name is. Aaliyah, what's your question? I don't know what your question is, Aaliyah, that you retracted. So let me know what your question is, Aaliyah, and we'll try to see what we can help you out with. All right, let's get on to the multiple choice. So the first one says the roots of the equation x squared minus 8x minus 20 is equal to 0. So what are the roots? And basically the roots is, really just another way for us to represent finding like the zeros of the equation. So that's basically what we're looking at. We're looking for the values of x that are going to make that true. So basically I'm looking for what 2 numbers multiply to give me negative 20, and then we're going to add to give me negative 8. So we think about, all the numbers that multiply to give you 20, 5, 4, 10, 2. And then I look at, well, 10 and 2, they have a difference of 8. So that would probably work. And since it needs to be a negative difference, that means I'm going to want 10 to be negative and the 2 to be positive. And if you multiply that out, you can see that that's going to give you exactly what we're working on. But we don't need to work that out. We just need to work that into the zero product property by setting each factor equal to 0. And you can see x is equal to 10 and x is equal to negative 2. So 10 and negative 2, 10 and negative 2, answer C. All right, the next one, I have the highlighter left in there for the answer, so we know what the answer, the sum of the solutions. Now we just need to figure out the solutions. And you can see here I have 4 terms. I think I said 3 terms when I was doing the video earlier. But when I have 4 terms, again, I'm going to want to use my grouping technique. So I'm going to group the first 2 terms, group the last 2 terms, and now look into factoring out the GCF. So when I factor out a common term here, you can see I can factor out a x squared. By factoring out the x squared, I'm left with a x minus 5. And now what I need to do is factor out the common terms of negative 9x and 45 so that I can still get an x minus 5. And I see that's going to be by factoring out a negative 9. And when I factor out a negative 9, I am left with a x minus 5. And now you can see out of these 2 terms, they both share a common x minus 5. Solve the equation and the sum of the solutions. Oh, yeah, okay. So now I can factor out the x minus 5. Oh, again, this is equal to 0. So I factor out the x minus 5, and therefore I'm left with a x squared minus 9, okay, equals 0. And you could write this as a linear factorization, or you can just see that the zeros are going to equal x equals 5 and x equals plus or minus 3. So plus or minus 3 obviously goes to 0, so therefore you're just left with 5, which is answer A. Question number 3 says, which of the following represents a complete factorization of this example? Now this is actually very similar to the one that we did in class. And the main idea is just seeing that these have common factors. Right? They have a common factor of 3x plus 1 raised to the 6th power. They're not the same, but I can factor out a 3x plus 1 to the 6th power. So let's go and do that. When I factor out a 3x plus 1 to the 6th power, what's left over is a 2. I have an extra 3x plus 1, so that's going to be a 3x plus 1. And then I have an extra negative 16x. So I factor that out. But you can obviously see that that's not one of my answer choices. So now what I'm going to do is want to simplify this example. So I go ahead and simplify this. So I have 3, not sure what I have here, 3x plus 1 to the 6th. This is going to give me a 6x plus 2 minus 16. And then we can simplify that again. 6x, oops, I forgot the x. Be careful. 6x minus 16 is a negative 10x. Actually, let's write that in front. Let's write the 2, because you can see they all wrote the x at the end. So I'm going to have a 2 minus 10x. Now again, I still don't have my answer here. But what I notice is these have a common factor of 2, right? So you can factor out that 2. And, you know, I'm going to just write this out once. If you factor out the 2, you're going to be left with 1 minus 5x. And you can see there's no 2 in between them, but all they did is they just put the 2 out in front. And you can see 1 minus 5x, that answer is B. All right, last but not least here is determine the equation whose roots are negative 1, negative 5, negative 3. That's kind of the same thing as like given the zeros. Now, rather than setting these each equal to 0, and then, you know, setting them equal to 0 and then finding out the factors, I'm just going to see, I can figure out that f of x is equal to these factors, x plus 1, x plus 5, and x plus 3. Okay. Now I'm going to do a little bit of distributive property here in my head to kind of keep this a little bit, you know, short. X times x is x squared. X times 5 is 5x. X times 1 is 1x. So 1x plus 5x is 6x. And then 1 times 5 is 5. So I multiplied these out, and now I need to multiply that times x plus 3. Now, I'm not going to do that in my head, even though I could do that in my head. For this one, I'm going to use the box method, actually, because I haven't done that in a while. So box method, you could do this by distributive property, which is perfectly fine. That's going to be kind of small. Yeah, let's do the box method down here. So the box method is just a way for us to represent the product of any 2 terms or expressions. Okay, and basically what you're going to do is put one expression on one side and another expression on the other. And you could use distributive property, but I kind of like organizing stuff like this. So this is x plus 3, and then my other one would be x squared plus 6x plus 5. Okay, because basically you're multiplying length times width, and you know length times width gives you area. And if you break up the area into different sections, the sum of all the areas of these boxes is going to add up to the area of the rectangle, which is the product of these two sides. Well, this nice thing about breaking these up here is all I got to do is find length times width of each one of these. So x times x squared is x cubed, x times 6x is 6x squared, x times 5 is 5x, x squared times 3 is 3x squared, 3 times 6x is going to be 18x, and 3 times 5 is 15. And what's nice about this is you can see that my like terms, rather than like trying to like find these or do these in your head, you can see that the like terms are on the diagonals. Okay, so now I can write my final answer here as x cubed plus 9x squared plus 23x plus 15. Now, I did the whole problem without actually trying to see if there was any shortcuts here. And I'm not seeing, oh, there's my answer. Yeah. So, you know, I'm not really sure if I might have been able to check this out. I think I really need to, you know, once you combine these, you see that's 9x squared. That's the only one that works, but you can see my answer is A. And then obviously I have some other ones for writing the equation, which are kind of some interesting ones to go ahead and think about for you on that. So, ladies and gentlemen, that's it. That is the homework on real zeros. Basically everything from solving via factoring as well as writing these zeros. And it's a really, really important, if there's one thing that I'm going to, you know, stress from this lesson, was understanding the importance of writing a polynomial as a linear factorization. Therefore, so you can understand the zeros as well as understand the multiplicity. Because, you know, one thing I've found, you know, teaching this section is a lot of students really struggle with the multiplicity, you know, algebraically, finding that multiplicity as well as graphically, like how the multiplicity is going to affect the graph. So either way, I hope that helps. I'll just go ahead and check in the chat, see if there's any questions. Looks like we do have some things going on here. So let me check back in. Ugly, dang. What is this? Lori, either denominator or numerator. Whoa, there's a lot of things. So let me kind of see coming up. So I am done with the live stream, but I'll come back up to you guys. All right, so let's see. I left off. Thank you for making the video. Thank you very much. You guys are really very welcome. Can you teach me slope point form? I get confused on solving for B. For example, M is -1/4 and the slope given is 2/4. Okay, so sorry, I'm going to pronounce your name incorrectly. So, but Sukhmeet Kayer, I can't even see if I have that clear, or Kayer. I'm not sure if that's an I or an L. Sorry, my eyes kind of seem. So he has a problem. Let's go down to an extra thing where we're given M is equal to -1/4, and the point that the line must go through is going to be 2, 6. And he's saying he's having a hard time solving for B. Well, that means you're using slope-intercept form, which is going to be y equals mx plus b. The other form that you could use is going to be point-slope form, which would be y minus y1 equals m times x minus x1. And that can be kind of confusing with the subscripts, so I'm actually going to solve both ways, and you can kind of decide which one you like. Yeah, so some people are helping them out. That's awesome. Thank you so much, Lori. That is sweet. Yeah, and I definitely I prefer to use point slope form for on this. Can you teach me how to graph sine and cosine functions? If you give me an equation, I will do my help. So I believe your name's Favor. How would you say it? So if you tell me an equation that you want me to talk about, I'll be more than happy to add on to it. So let's go and just kind of take a look at this, because I like talking with slope point slope form first, because if you're looking at a point, let's call our point, you know, x1, y1. All right. So you can see here that this can be represented as x1 and this can be represented as y1. And then obviously m is our slope. So by plugging these points in, we can say y minus 6 equals -1/4 times x minus 2. Okay, And therefore, that's the equation of the line. Now, obviously, some people want to go ahead and have this solve for y. So what I'll do is I'll distribute the negative 1/4, and then I'll add the 6 to the other side. So therefore, I have y is equal to negative 1/4 x. Negative 1/4 times negative 2 is going to be a positive 1/2 plus 6. And if I needed to add 1/2 plus 6, I can put the 6 over 1, multiply that by 2 over 2, and I'd have 1/6 plus 12 over, no, 1/2. Oops, let's erase that. So I'd have 1/2 plus 12 over 2, which gives me a 13 over 2. So that's a little sidebar. Okay, so therefore I have y equals negative 1/4 x plus 13 over 2. And that's not very nice, like as far as graphing it, because obviously your b is going to be a fraction 13 over 2, which, you know, might be helpful to rewrite as a mixed number. So you can kind of see like the decimal version of that, which would be 2 goes into 13 4 times, so it'd be 4.5, right? Now let's go and do this the other way. Let's do it with this way. Y equals mx plus b. So the process is the same, but now rather than treating our point x1, y1, we're going to treat our point just as x and y. And we're going to use the same m. So we'd have y equals, no, not y equals, y is now equal to 6. So we can say 6 is equal to negative 1 over 4 x and then plus b. So why am I doing this? Not x, we have x. X is 2 plus b. Okay, well, if I need to solve for b here, basically what I'm doing is I need to multiply this out. So 2 times 1/4 is going to be 6 is equal to negative 1/2 plus b. Now to solve for b, you need to add 1/2. And again, we already did that. 6 plus 1/2 is going to be 13 halves. So it's really, I'm not sure if it's your understanding of the problem or how to do it, but it's really the understanding with fractions. And then again, now you just go back to your y equals mx plus b form and you replace b with 13 halves. And then there you go. You're all set. So anyways, I hope that helped you out. Please try 9 plus 10. I keep on getting 21. Well, find something that you have 9 of and find something you have 10 of, combine them together, and then count how many you have total, and you'll get 19. What up, guys? Julie here. How do you put this equation in y standard form? M equals 3, and I'm given 2 points, 2/3 and 1/4. Segment. All right, you're getting there. So, Fair, if you got some equations on sign, I mean, I'll do more of these for you guys, but if you guys have any other questions for sign, maybe I'll do one or more of these. Do you do trig, sir? Yes, I will be starting trig. My King will be doing trig here in probably about 2 weeks. So obviously I have a whole bunch of videos on trig already, but if you want to follow my kind of homework and my quizzes, obviously you can go ahead and check out my trig there. I'll also have additional worksheets and, you know, all the homework and stuff like that, but I'm working on that stuff, you know, in time. If you, obviously when you look into a sponsorship or a Patreon, you guys can see you'll get access to all of my content. If that's something you like, if you just like the videos, then you're in the right place as far as on YouTube. So trig is light work. I like that. All right. Well, I guess I'll do another problem here for linear equations for Sukmi. And then if you guys have any other questions, maybe I'll try to fix it in. So again, I'm just going to use the point slope form. Rather than doing both forms, I'm just going to use this as y minus y1 equals m times x minus x1. Okay? Where my point is going to be x1 comma y1. So let's just replace this. You can see here, this is x1, comma y1. Okay, so let's replace with x1, let's replace that with 2/3. For y1, let's replace that with 1/4. For m, let's replace that with 2. So we'll have y minus 1/4 is equal to 2 times x minus 2/3. Okay, so again, we're going to distribute property and then add the 1/4. So I'm just going to move my work over here. So therefore I have y is equal to a 2x. 2 times negative 2/3 is a negative 4/3. And then add 1/4. Well, to add these fractions, you got to get common denominators. The common denominator of 3 and 4 is 12. So I'm going to multiply by 4 over 4 and 3 over 3. So therefore what I have is y is equal to 2x. Let's see, minus a 16 over 12 plus a 3 over 12. And remember that's a negative, so therefore I get a y equals a 2x minus 13/12. And there you go. That is your answer. Hopefully that helped you out. I got a 7. Be my tutor. You guys, anyone listen to a little? Okay. Base in A. So I guess that is it. I guess that is it for the questions. I'll be back next week for a live stream. So again, guys, if you want to kind of get notified, I'll try to get out. If you are a part of the Patreon or a part of the channel membership, I am trying to get used to like making sure I let you guys know when I'm going to be live streaming. Obviously, the day of, or even the day before, if I am really organized, I will make sure that I set it up on YouTube. So therefore, you guys are all notified, especially those of you who have like the bell notification or whatever else. But obviously, as you mentioned, if you've kind of noticed like this week, sometimes I don't have time to get everything organized and scheduled. So I just have to go live. So obviously, if you guys are constantly on YouTube around this time, and this is usually my times that I'll be go ahead and getting live. But I got to go. I got to pick up my children, and it is 5 o'clock. So I'm going to say peace out to you guys. It was enjoyable here with you, and I'll catch you guys on the next stream.